Hi guys, so we're going to be solving this question from the Woods and Raphael's digital imaging textbook. So it says let the set V be equal to 0, 1, and 2. Basically, the set V defines the allowed numbers we can walk through in the path and compute the length of the shortest 8, 4, and M path between P and Q. If a particular path does not exist between the 2 points, explain why. So we're giving this as the matrix. I'm just going to write it quickly. So now this is the path. For the first one, with the set V equals to 0, 1, 2, 0, 1, 2. This is P and this is Q. Now you see, to even start the path, you have to ensure that the value of P and the value of Q are in the set V. Yes, the value of Q is in the set V, but the value of P is not in the set V. Therefore, you can't even start this path because you're not allowed to step on values that are not in V. So, personally for me, I'll say that there's no valid path for this particular, if you're using this particular set, there's no valid path whether for 8 or M, you can't even start. So let's move on to the second one where it's 2, 3, and 4. So we're going to first start with the 4 path. So for the 4 path, we're first going to start there. 4 path, you can basically only make up, down, side, side movement. So let's say this is a pixel, for instance. This is a pixel. You can only make 1, 2, 3, 4. You can only move in this direction. So we're starting from P. We can go up, we can go side, and we can go down. And the question is, which one can we step on? You can only step on values that are in the set V. So in this case, we can go up because 2 is in the set V. We can come to this side. We can go from 2 to 3 because 3 is in the set V. We can come down to 4. Next, we can move to 2 because 2 is still in the set V. Next, we can move to is 3 because 3 is in set V. And lastly, we can only move in this direction. Therefore, there is actually no, if you're using the 4 path, there's actually no route from P to Q if you're using the 4 path. And let's move on to the 8th path. In the 8th path, you can make diagonal movement. So imagine this is the grid. This is the center pixel P. You can make diagonal movements now. And also the normal north, west, south, and east movement. So if I'm just going to erase this and start again. So for 8th path, we can make diagonal movement. So we're starting from P. We can easily just move straight to 2 rather than coming here, then going to this point. Next, we can move straight to 3 because 3 is in the set V. We cannot move to 1, we cannot move to 0, and we cannot move backwards. Next, we're going to move to 4. 4 is in the set V, and we can make diagonal moves in 8th path. We cannot move to 0. We don't want to move downwards because that's moving away from Q, and we cannot move to 1. So this is actually the next option to move to. Next, from here, you can just move straight to Q. So yes, there is an 8th path. I believe this is the shortest path. You can try other ways you can reach Q using the 8th path and see if this is the shorter path. Now for M adjacency, this one is M path. This one is a bit tricky. The M path has a few rules. So all 4 neighbor moves are around, and if you want to make a north, south, east, west movement, it is allowed. So it's the other way around, west, east. It's allowed as long as that particular value you're moving to is in the set V. However, if you want to make a diagonal move, the common phone neighbor of Q and P, that's the pixel you are at to the pixel you're moving to, their common phone neighbor should not be found in set V. So enough talk, let me just show you what it means. Let's start again. Let's say for instance, I wanted to move from this M adjacency, M path, I want to move from here to this point. To make a diagonal, so first I'm going to check what's the common phone neighbor of 3. It is 2, 0, and 1. What is the common phone neighbor of the pixel you're moving to? It is 1, 3, 0, and 2. What is the intersection of the common neighbor between 3 and 2? You can see they are both sharing this phone neighbor. So 2 and 0. Now check if 2 or 0 is in the set V. We find that 2 is in the set V. Therefore, we cannot make this move. That's just what that rule means. So we're going to have to move up. Now we can make four adjacent moves, like I said. We can move to the side now because that value has 2. Next, we can move to 3 because 3 is in the set V. Next, we check if we can make a 4 neighbor move from here. You see that the 4 neighbor is 0, 4, and 1, and 2 as well, but we don't want to move backwards. So 4 is not in set V, 1 is not in set V, 0 is not in set V. So we have no other choice than to make a diagonal movement. But remember, we actually have to check it is a valid diagonal movement. So their common 4 neighbor in this case is 0 and 1. The 0 and 1. Check if it's in the set V. You see that no, it's not in the set V, therefore this move is valid to make. We can make this diagonal move. Lastly, we just move using a 4 path movement. So this will be the shortest path. You can shall experiment and find out if there's another shorter path to use. So this will be the final answer. Thank you for listening. Anything you do not understand, do not hesitate to ask in the comment section. Thank you.